So for this, solving the system, instead of doing it by substitution and elimination, they said to do it by the graphing way. All right. So if you were to do this, I think the easiest way it might work is that generally it's a lot easier when you can graph in the y equals mx plus b method. So what I mean is I'm gonna just switch this around. So let's say I name this 1 and name this 2. For number 1, I'm gonna write that it's 2y plus x plus 4 equals 0. I want to get my y by itself. And so for all of these, I'm gonna get the equations to y equals mx plus b form. And so I have minus x minus 4 on the left, minus x minus 4 on the left, and I have 2y is equal to negative x minus 4. I want to get the y by itself, so I'm going to divide by 2 on all three. So I get y is equal to negative x divided by 2 minus 2. So what that really is negative 1 over 2x minus 2, where this is the rise and this is the run, okay? So let me also simplify the second one. The second one, it says it's negative x equals negative 8 minus 2y. You want to, again, get y by itself, so I'm going to move that one over. To get rid of negative 8, I have to do the opposite, and I add 8. And so I'm just going to move this to the left, so what I mean is I'm just going to switch the size, do a switcheroo. So I have negative 2y equals negative x plus 8. I want to get y by itself, so I'm going to divide everything by negative 2. And so I have y is equal to 1 over 2, or 1 over 2x minus 4. So just because I noticed something, I'm going to highlight that this is my first equation and this other one is my second equation, okay? And it's going to be a lot easier to graph now that it's in the slope-intercept form. So what I noticed is that in this case, this is the rise. In this case, this is the run. So I'm going to start off with one equation at a time. So again, it might not be my most preferred way to solve the system by graphing. In fact, I usually prefer the algebraic method, which is either substitution or elimination. But it's important to know that you can also do it this way, right? So what you do is you start off at the y-intercept, which is right there. So I'm going to draw a dot there. And although with fractions it looks hard, if we break it down like I did for here, it's actually not too bad. Hopefully you see that. What I mean is I'm going to go down 1 and then run 2, down 1, run 2. You're going to do like a mirror effect on the other side. So you're going to go, you're going to rise 1 and left 2. You're going to kind of like do the opposite of what you did. You're going to go up 1, left 2. Going to draw that line. Okay. And draw the arrows. And that represents equation 1. Okay. And next, let's do the green one. So we're going to start off at a y-intercept of negative 4. So that's negative 4. I'm going to go up 1, run 2. So up 1, run 2. Ah, look. Up 1, run 2. So I'm noticing that the line is actually right there and like there. So the reason I didn't like the graphing method is like sometimes you can't really tell what the POI is, because what if it's like in between? What if it's like here and there? But this one works out nicely, so that means that is the POI, because that's what you're doing when you're trying to solve for a system. And so I am noticing that, well, this is the x and this is the y, and we always write the x first and then the y. So that means the x is 2 and the y is negative 3. So my POI is 2 comma negative 3. And you're just going to conclude that. So you're going to say, therefore, the POI is 2 comma negative 3. And you're done.